All right, let's start the exam one review. I'm going to try my best to give you some good advice for test two, the unit two test. So the first two questions, I'll just tell you right now, let me write it down. Just use your calculator. Nothing crazy. No work is required for those. It's just make sure you are in radians or degrees. And you'll know by looking at the answers. And if your answer's not there, then change to degrees or radians. Number three is a word problem. It's pretty chill, something like this one here. Let's see. So an airplane flies at an added altitude um, of A equal to 6 miles toward a point directly over an observer. Consider theta and x as your variables. Write theta as a function of x. Okay, so let me give you a figure to make it a little easier. So let's say the plane's over here flying somewhere. Altitude is the height, right? So this is A. The observer will be down here. We'll say he's looking up, hanging out down here. Right triangle, so I can apply a lot of properties. So I'm looking upward. A is 6, right? So if they want me to write theta as a function of x, we would have to solve for theta. But let's build the triangle, the function first before we do any of that. We know, right? We'll call this x. That tangent of theta is equal to the opposite over adjacent. So back in test one material. But now if I were to do the inverse of both sides or use the definition, however you want to think about it, then I have a function of theta in terms of x. So this is what they want right here. Or arc sine. Okay. All right. So this is the type of work you need to show. Whether they give you the triangle or not, you need to build it. And then solve for theta because they wanted theta in terms of x. All right, let's move on. Question four is kind of like one of these from the ending of chapter four. So there's a little bit of inverse questions in this exam, so that's why I'm covering them. Uh, but remember, we said in order to do this guy, we're basically looking for cosine of theta. So we define theta as uh, a triangle being built with this. So the way you start, whether it's general or numbers, is let the theta equal the inside part, the inverse part, and then use the definition. Sine theta equals to 40 over 41. Can either think of it as taking sine of both sides or you applying the definition. Okay. Alrighty. Now, using that information, build your triangle. So this will be opposite over hypotenuse. You got to find this missing side. So do your Pythagorean theorem. Okay, so I'm missing one of the sides. Subtract the 40 over here. Square root both sides. And we get A equal to 9. Okay, so now we can answer the question, well, what is cosine, right? So cosine of sine inverse of 40 over 41 is equal to cosine of theta, because we said theta is this. Now looking at the triangle, cosine is the adjacent over hypotenuse. So we have our answer right here. All right. So use the inside to define theta. Once you do, use that to build your triangle, solve for all the sides, and then answer the question. What is the cosine? Oops, this is parentheses. All right, let's go to the next one. Number 5 is about building your triangle using some information, right? And then answer the question. So they're going to say find sine, cosine, or just state them. And secant. We already have cosine, but whatever. Okay. So since sine x is positive, that's what this means. And obviously cosine is positive, so 1/4. That means that we are in quadrant 1. So you could go through the answers and eliminate a lot of them. Anything with a minus sign would be wrong because it has to be quadrant 1. Now, you still got to show your work though, because that's what matters, not the choosing an answer. All right, so build your triangle. Adjacent over hypotenuse. Find the missing side. So we got to do our Pythagorean. Subtract the 1 over. So B is square root both sides, right? Is equal to square root of 16 minus 1. So B is 5. Plus or minus technically, but we're choosing positive because we're quadrant 1. So B positive. Now you can just list off all of them. Sine is opposite over hypotenuse. Cosine is already found, but there it is. Tangent is adjacent over, sorry, opposite over adjacent. Secant is just 4 over 1. And that's it. So these are your answers. So use this information, remember which quadrant we're in, build your triangle, and you're done. So you'll have one of these on something like this for number five. Okay, let's move on. Okay. Number six, just basically explain and show how to simplify. Okay. We're not proving anything on this one, just simplify it. And then state how you did it. So you can see right here that this is the same. Well, we'll go down, I guess. I think we call it quotient or ratio property. So then this becomes cosine theta over sine theta. Simplifies to cosine. So that's all I want to. So just show me this. Like if you have something like that, just simplify it because clearly things cancel. Okay. And if they say, is this, if they say simplify is what they want you to do, if they say show which one it's equivalent to in your multiple choice, then you got to simplify it and then pick your answer. Okay, this next one, they say solve the equation. Notice they don't say between 0 to 2 pi, they just say solve it. So just gotta tack on the plus 2k pi or plus pi k or whatever. So this is a simple factorization. So notice they both have cosine in common, so factor out cosine, and we're left with 2, 2 cosine minus 1. So now equate each one to 0 because we're factored, and you can solve for cosine, isolate the cosine part, add the 1 over, and then divide by 2. That'll get us to here. So now when does this happen and when does that happen? Well, cosine is 0 when theta is pi over 2 and 3 pi over 2. I'm just using the unit circle. And then cosine is 1/2, positive 1/2 at pi over 3 and 5 pi over 3. It's just using your circle, we find these answers. Okay. So number eight will be something like that. Just solve the equation in general for all solutions. So we have to tack on the k pi. Now, these are separated by 90 degrees or pi over 2. I'm sorry, or they're separated by 180. So you can actually combine this, not your first set of solutions. We'll call it theta 1. Theta pi over 2 plus k pi. 5 pi over 3. Let me open my circle. One moment. Okay, pi thirds and 5 pi thirds are not at separate and not at 180 degrees. So these will be plus k pi, 2k pi. So they would combine these two by saying if I add pi over 2 to this one, I'll just land on there and then add a pi again. I'll land over here, land pi again, and just cycle. And these two, I can't combine them into one, so they're just separate. So this answer plus that, this answer plus that. I mean, you could do it the same for these two separately, but this is a more compact answer. If you just add 2 pi k, I'm not gonna mark it wrong, but you should see that you can combine these two solutions with this pi over 2 plus k pi. Now let's move on to something else. All right, so number nine is, I'm gonna skip number nine, just make a note. Solve a tangent equation. So go in your homework for five, I think it was, and solve a tan equation on a single period. Then you should be good. Number 10 is a lot harder, so I'm gonna focus on this. Uh, so basically, I want us to find sine of u and v, given that this is sine u and this is cosine v. So we're gonna have to, what's it called? Build two separate triangles for u and one for v using that information. And then plug all that stuff into this formula. That's what we're going to use in a minute. So I wrote it all out so you know what we're using. So build your triangles. Fucking stop. Sorry. I want somebody a message and I got distracted. All right. So here we go. Sine u is 3 over 5. So opposite over adjacent. Cosine v is adjacent negative. Hypotenuse is never negative, by the way. Just make it positive. 25. No, need to make it we need the missing side. I know this one's gonna be 4 and okay. So I'm skipping the Pythagorean. So you're gonna have to find the three sides. Uh, what was missing was the 4 on this one and the 7 on that guy. Once you have that, notice how we're gonna need uh, both the sine and cosine for both triangles. So now we can say, okay, well, sine u is given to us, but now I have cosine u, so I can use it as part of this. Sine v is right there, opposite over hypotenuse. Now we can fill in this blank. So let me write the formula in terms of u, or these blanks here. In terms of u and v, that'd be equal to sine V cosine, I'm sorry, cosine U cosine V plus cosine U sine V over cosine U times cosine V. Oops, there we go. So now that we have all that, just plug it in and we're pretty much good. Then we can use your calculator or just add the fractions and we're done. Okay, so this will be sine u is right there. 3/5 times cosine V, a negative 24.25 plus cosine u, which is negative, shoot, that should be a V right there. Cosine u, which is, oh no, shoot, I made a mistake right here. Cosine u is adjacent over hypotenuse, so this one's good, plus cosine u, so this is the 4/5 right here, times sine v, which is up here, times cosine u, cosine v, and there we go. We have everything ready to go. I mean, if you put this in, your calculator, you'll get it right away. Um, do it piece by piece also would be fine. But yeah, if you get this far, I mean, I would give you all the credit. If you make a small error on the fractions, I'm not gonna get mad about it. Be a little sad about it, but it's all good. Anyway, so it'll all reduce into negative 4/5. Number 11 is gonna be a sum and difference type formula, so that's gonna be whenever you get something like this is not on the circle, I don't think. Let me check, actually. Actually, this one is. Let me pick a more interesting one. Sorry about that. Okay, sine of 75 is better. So that's not on the circle. Therefore, I have to use sine and difference formula and say, well, I'm going to break this up into sine of 30 degrees plus sine plus 45 degrees. So I purposely picked it because you can break this into two angles that are on the circle. Okay. Just remember, we can use this formula. Sine A times cosine B plus cosine A times sine B. So this is my A and B. So sine of 75 is equal to sine, let me use the formula right here. So it'll be sine 30 times cosine 45 plus cosine 30 times sine 45. So now just look it up on your circle and we should be good. This will be Let me get my circle out. Sine of 30 is 1/2. Cosine 45, well, that's the common angle. Cosine 30, that will be √3/2. Sine 45 will be this. And that's it. We can combine them, but that's pretty much it. Okay. Sorry, there's my answer. And we can move on to the next one. Okay. Cosine 2 theta minus cosine theta equal -1. That's then they want us to find it on one period. So just go around the circle and find all the solutions. Once we're done, then we'll be good. Seeing the double angle is a problem because I can't do anything. So we're going to use a double angle formula. So remember, the cosine, there's three different versions, but I'm going to use this one. Okay, and then we're going to change cosine 2 theta into 2 cosine theta squared minus cosine. So right here, I applied the double angle. Then I'm going to factor cosine from both. Well, actually, let's set it to 0 first. So I'm going to add 1 to both sides. That'll cancel the ones. So now I have 2 cosine squared theta minus cosine theta equal to 0. Factor cosine, and now we can set each one equal to 0 because of the zero factor property. So for cosine, getting us to here. So now just look on the circle. When is cosine 0? Since it's just one period or one revolution, these are good enough. Now when is cosine 1/2? That'll be these two. And you're done. Okay, so number 14 and 15 are just using your product to sum. So make sure you have those formulas. They're just pretty straight up. Just plug in your numbers. Um, so that's 14, 15. 16, you'll have to set one side to use the sum of difference on one side and try to simplify it. But we'll stop here. I'll leave the rest to you. But 14, 15 are pretty easy. 16 is a little challenging, but not too bad. But that's pretty much most of them.